My name is Jennifer Miller, and this is a presentation on the UV index measurables collected for a 14-day period. The contents of this project include the resource of OpenUV to collect the hourly and daily UV index data, the sun times, and within that data to calculate the average and highest UV index measurables. The expected implementation of this project was to have a 14-day period to analyze current UV index data in East Central Florida. This would be using the Open Weather API, and the data collected will be used to calculate the average UV index, the highest and lowest UV indexes, and the hourly changes during the day. The actual implementation was still a 14-day period that analyzed current UV index data in East Central Florida. But however, we used the OpenUV API, and the lowest UV index is automatically 0 when there is no UV to collect. Therefore, the measurables were only the average, the maximum UV, and still the hourly changes throughout the day. The languages used during this project were JSON, JavaScript, and HTML, and those languages were used within the API and Visual Studio Code. Day 1 of our collection period was November 7th, 2022. On the left is a line graph to illustrate the data collected using the standard practice of Zulu time. On the right lists some additional information for the data collected to include sunrise, sunset, and the UV max. Day 2 of our collection period was November 8th, 2022. By looking at the line graph and the additional data on the right, we can start to see the downfall of the UV index and the time difference where sunrise, sunset, and other sun times are pushed to the right. Day 3 of our collection period was November 9th, 2022. This is where we can see a heavy decrease in the average UV index for that day, which could be a result of an increase in cloud coverage or a cold front. Day 4 of our collection period was November 10th, 2022, where the UV max index is the same as November 9th. However, the average UV index increased, which could be a result of weather change. Day 5 of our collection period was November 11th, 2022. This data collection did not have many differences as the prior collections, except for the slight decrease in the average UV index and the slight push to the right of sun times. Day 6 of our collection period was November 12th, 2022, where we can see a decrease in the average UV index, the UV max index, and the sun times. Day 7 of our collection was November 13th, 2022, wrapping up our first week of the data collection period. November 13th's data only showed the decrease in average UV index and the sun times, which could be a result of seasonal or weather change. Day 8 of our collection period was November 14th, 2022, which is still consistent with the decrease in the average UV index and the sun times. Day 9 of our collection period was November 15th, 2022, which still shows the constant decrease of the average UV index and the sun times. However, there is a very slight increase in the UV max. Day 10 of our collection period was November 16th, 2022, which showed the consistency of the decrease in average UV index and sun times, as well as a decrease in the UV max. Day 11 of our collection period was November 17th, 2022, which only showed the consistency and decrease of the average UV index and the sun times. Day 12 of our collection period was November 18th, 2022, which showed the consistency and decrease of the average UV index and the sun times. Day 13 of the collection period was November 19th, 2022, which showed the consistency and decrease of the average UV index and the sun times. Day 14 of our collection period was November 20th, 2022, which wrapped up both the second week of our collection period and the collection period in its entirety. This data collection showed the consistency and decrease of the average UV index and sun times, as well as our last decrease in the UV max. Each collection day of hourly data was calculated for a daily average UV index, where on the left side is a double line graph showing a comparison between each day's average UV index versus their UV max index. Both show a steady decrease, and on the right side is the average UV max index for the entire collection period, as well as its reflective max index time range to show that within the 14 days, the UV max was not consistently at the same time each day. This project did not require any additional hardware, therefore the only technical challenge we saw was when a computer was running slowly, which affected our time management and data collection procedures. Successes found during this project was we were able to collect during our entire expected 14-day period by each hour from sunrise to sunset, and we were able to use the data collected to calculate accurate measurables for the averages and maximum UV indexes. The disappointment during this project was the chart design. There were some limitations where I would have liked to add a couple of more data points, for example, plotting the UV max on each day's line graph. Some recommendations I would make for a revision would be to collect a 14-day period per season so we can compare how the UV index varies throughout the calendar year. Also color coding the line graphs for safety levels so we can be able to understand what these UV indexes mean, and also to add additional line graphs and charts for the sun times, especially if we were doing one full calendar year, we can see how time affects the UV indexes. Thank you for listening to my presentation.